In this video, we'll be talking about the general properties of bonds. Let's not waste any of your time. Let's get right to it. Now, when we're talking general properties of a bond, what we're referring to is those moments when atoms interact with each other in a variety of settings, and we'll talk about a majority of them, but we're talking about two atoms that form some kind of a bond: ionic bond, covalent bond, hydrogen bond. There are others. That's the three that we're going to focus on. When that happens, it's all about the electrons. Okay, we talked about electrons being super important in an atom. They're the only ones that can be exchanged, working. Protons and neutrons are inside the nucleus, and they cannot. But when an atom is involved in a bond, it can gain or lose or share electrons, and all that's listed there. If it gains or loses, then it's an ionic bond and it becomes an ion, which we discussed in our last video. It can be a positive ion or a negative ion. If it shares the electrons, that's a covalent bond. Okay, other ways it can be identified: if it loses an electron, it's considered to be a cation, and cations are elements that are found in those first two rows on the far left of a periodic table. Anions are atoms that gain electrons, and they are typically found in the right third of a periodic table. Okay, other concepts to consider when we're talking general properties of a bond is the word valence. We will talk about valence quite a bit. If you are in a chemistry class, you will talk valence all year long to some degree. But the word valence refers to outer, okay, or outermost. Okay, and so when it comes to shells, when we say valence shells, we're talking about the outer shell or the last shell. As you can see in the diagram, this particular atom uses three shells to place or house its electrons. And so the outer shell or the valence shell would be the third shell. Now, we recall that there are 7 total, but the 4th, 5th, 6th, and 7th are not used for valence to house electrons, so they're not a part of the valence identification. The word valence means outer. In this case, the third shell is the most outer one used, and so that is the valence shell. The valence electrons are electrons on the outer shell. In this case, it would be the electrons on the third shell. Now, we're also referring to the octet rule when we have our discussions. The octet rule is a rule that atoms want to have 8 electrons on their outer shell. They may have more inward rings or rings closer to the middle, but 8 is the number they're looking for. That means the outer shell is full, okay, and it is inert, which means it doesn't react anymore or doesn't have any more bonds with atoms. That's the octet rule. Okay, now the idea of, got some examples here, but a rule, it's not a hard and fast rule as we like rules to be, but in this case, the number 5 is kind of that point where electrons can be gained or lost. If it has less than 5, it typically loses those electrons to stronger ones. If it has 5 or more, it typically gains electrons to fill its outer shell. That's not always the case. as when we look at carbon in chapter 3, we'll see that a bunch. But the idea of what will happen, or if you're looking at an atom and kind of getting a general sense of is it going to gain electrons or lose electrons. 5 is kind of that number. If you're in a chemistry class, you've talked a lot about electron configuration and atoms and have that depth of knowledge. But if you look at like a hydrogen, it has 1 on its outer shell. The first shell can only hold 2. So hydrogen does not have a full shell, so it will react or bond with elements. It has 1, which is certainly less than 5, so it would be looking to lose its electron on its outer ring. Helium, which is in that far right-hand side column, the inert gases, it has 2 and a full outer shell, and it's a tricky one. Helium's the one that's tricky because it doesn't have the octet rule in mind. It doesn't have a second ring, so it doesn't have enough electrons to kind of fit along with everything else. So it's a tricky one to look at, but it's a full outer ring. It will not bond. If we look at lithium, lithium has 1 valence electron on its valence shell, so that's certainly less than 5. It will be looking to give up that electron and then fall back to the first ring, which is full. That's what it's trying to do, get a full outer shell. Carbon is the one that's really a tricky one. It's in that 4 group. It's got 4 valence electrons. We'll learn a lot more about that in chapter 3, but it has 4. It will be looking to get 4 more or be a part of 4 to get to the octet rule. Fluorine, as you can see, has 7 valence electrons on its valence shell, so it needs 1 to meet the octet rule. So we'll be looking to bond with somebody who has 1 electron to give up. The last one, neon, as you can see, it has 8 valence electrons on its valence shell, so it has a full shell. It will not bond. It's part of those noble gases that do not bond with things because they have a full outer shell. And our last slide to consider, we have 3 types of bonds that we're going to deal with. Covalent bonds, which share electrons. Hydrogen bonds, which take electrons, or you gain or lose electrons. And a hydrogen bond, which you think would be a bond between 2 hydrogen atoms. That is not the case. It is a bond between a hydrogen atom of 1 molecule and the main element of another molecule. And we'll have each of those has their own little video where we will get into those. So that's our show for today. The next time we get together, we'll be looking at covalent bonds. We'll see you then.